With radiation, a spherical tumor can continue to shrink even after radiation has completed. So we have our shape. It's a sphere. The spherical tumor is expected to shrink by 0.12 centimeters per week after radiation is completed. So you get radiation. That shrinks the tumor a little bit, but also the point of radiation is that it stays in your body and it continues to fight off the cancer so that it'll make it smaller and smaller even without having another radiation treatment. So this time it's shrinking by 0.12 centimeters per week. Find how rapidly the volume of the tumor is decreasing. So we want to find how the volume of the tumor is decreasing when the radius of the tumor is 4 centimeters at the time of treatment than when it's completed. So we're going to use the volume of the sphere again. So our equation is that we have the volume is equal to 4/3 pi r cubed, which is nice because we actually just took the derivative of this in the last page. We're not going to forget any of our dv, dt's, or dr/dt's this time. So there's our equation. We're going to figure out, do we know the volume? Do we know the radius? And do we know how fast each one's changing with respect to time? We should know one of them and be solving for the other. So we know this tumor is shrinking by 0.12 centimeters per week. So it doesn't explicitly say whether that is dv, dt, or dr, dt. So let's try to investigate further. The other thing we have is the radius of the tumor is 4 centimeters. So if r is centimeters, dr dt is going to be centimeters per, and our time, this one is weeks. And if the radius is in centimeters, volume is going to be centimeters cubed, making dv dt in centimeters cubed per week. So now let's figure out, what does that 0.12 have to be? The spherical tumor is expected to shrink by 0.12 centimeters per week. That has to be dr dt. If it was dv dt, it would be centimeters cubed per week. But because it's not cubed, it's not volume. Squared is area, cubed is volume. This one is just regular centimeters. That must be how the radius is changing per week. And it's 0.12, but it's shrinking by 0.12. So should this be positive or negative? It should be negative 0.12 per week. We want to find how fast the volume of the tumor is decreasing when this happens. So we're asked to find dv dt. If we wanted to know the original volume of the tumor, we would plug in 4 for r, and that would tell us the original volume of the tumor. But let's see if we even need that v. We're going to go ahead and take the derivative and see if we can get by without it. So the derivative of v, 1v is just going to be 1 dv dt. And then we're going to do our 4/3 pi r cubed. We just did this one. We're going to bring down the 3. 3 times 4/3 is just going to be 4 pi r squared. And then we want to remember to put our dr dt. And the radius is changing with respect to time. So this one's kind of nice because we're solving for dv dt. And our equation is solved for dv dt. So we won't have to do any moving. So dv dt is going to be 4 pi times our radius. The original radius is 4, and that's getting squared, times dr dt, which is a negative 0.12. So dv dt, we would just multiply these together. We remember to do PEMDAS, so we would do 4 squared first, times 4 pi, times negative 0.12, and I'm not even going to multiply the pi, I'm going to leave it as negative 7.68 pi centimeters cubed per week. So let's interpret and see if this answer that we got makes sense. So first start with what we're given. So as the radius says what? Increases or decreases? It says it's shrinking. So you could say shrink or decrease. So maybe use shrink because it's specific to this problem. As the radius shrinks by 0.12 centimeters per week, the volume does what? Does the volume of the tumor increase or decrease? We would say it decreases or shrinks. Maybe say it decreases for this one. The volume decreases by 7.68 cubic centimeters per week, which is great. The tumor is shrinking as the radius is shrinking.